Hi everyone. So today we will talk about welding of plastics, ceramics and composites. So these are non-metals. So we have already seen or talked about welding of metals. So today we'll talk about non-metals, how the non-metals are welded. So mainly welding is required in case of ceramics. Actually it's a joining process, so we cannot say always the welding, it can be joining. So there are other methods of joining apart from welding. So let us see. We will start with the plastics. So before going to the topic, let us see some of the questions which are like asked in the previous year examinations. So I have observed 2020 last year there was no question from this topic, but in 17 I have seen, actually in 18 and 19 I don't have paper. So if you can find, you check what are the different types of questions asked from this topic. Okay, like here is one question: explain the welding technology used to weld ceramics. Okay, another is about the short notes on plastic welding. Then there is discuss the method for joining of ceramics with other metals. Okay, so it's talking about ceramics and plastics. And there was one more, that is composites. So we haven't so I haven't seen any question on composites, but we will talk about that. So first of all, let us talk about the plastics. So plastic actually comes under polymeric materials. So polymers are divided into two parts: plastics and elastomers. And plastics are two types: one is thermoplastic and thermosetting plastic, or you can say thermosetting materials. So thermoplastic and thermosetting materials both are actually divided into commodity plastics and engineering plastics. The like objects which we use for general day-to-day purpose, and engineering plastics are basically which is used for like construction purpose, construction of different tools, different machineries, and construction of like different buildings and all. So many other uses are there. So under commodity plastics, in thermoplastic comes polyethylene, we say it as polythene also, polypropylene, polystyrene, PVC, ABS. These are some of the commodity plastics. Engineering plastics are polyamides, acetals, cellulose, jigs, polycarbonate. Many other are also there. In thermosetting plastics, what is thermosetting? We will talk about that. The commodity plastics are phenolics, unsaturated polyesters, and ureas. And engineering plastics are silicones, urethanes, melamines, others. So these are some of the different plastics. So let us talk about thermoplastic, what it is. So actually the difference between thermosetting and thermoplastics are that the thermoplastics is can be recycled. That means once melted it solidifies, after that you can melt and use it. Okay, but in case of thermosetting, it is not possible. Once it is after melting, once it is solidified, after that you cannot do anything, like you cannot reuse it, you cannot remelt and again use it. So that is thermosettings. So here this plastics, it is softened and melted by heat and then formed into different shapes. Okay, so these are actually once melted, after once solidified it cannot be melted again. Okay, and these materials, actually the raw materials are known as resins. So generally we will hear the term thermosetting resins. So these resins are mixed and placed in the mold and heated, and then it is compressed, and after that we get the strength and hardness. So actually thermosetting materials have more hardness and more strength than the thermoplastics materials. Now there are four methods by which plastics are joined. One is like by cementing with a solvent. Okay. Another method of joining plastics is by using an adhesives. This method can be used for all plastics. So we use, actually mainly we have already seen in welding, there are three methods of joining. One is mechanical joining by using nut, bolts and rivets. Okay, and one is adhesive joining with the help of resins or glues, and another one is welding. So that same methods we will be using, and one extra method is cementing. Okay, so joining of plastics are done by four methods. One is, first is mechanical joining, that is by using fasteners like bolts, screws, nuts and rivets. Another one is adhesive joining, with the help of adhesives we join. And third one is welding, and the fourth one is cementing, that is extra one. So adhesives we can use, here we can use welding. Okay, except a few inflammable plastics. There are some plastic which catches fire very fast, so they are not welded, actually they never welded. Under a welding process there are hot gas welding, heated tool welding, friction and induction heating. So these are some of the uh, welding methods. And then we use fasteners also for joining the plastics, that is bolt, screws, nuts and rivets. Okay, so this depends on the various applications, which kind of joining method we are going to use. That depends on the various applications. Okay, and the type of plastic, which kind of plastic we are using. Okay, so if we are going for thermosetting plastics, then obviously we will be going for generally it is used fasteners. Okay, like mechanical fasteners. So it depends on the type and the application. So let's us talk about plastic welding. So we are mainly we will be talking now about the thermoplastics, how the thermoplastics are welded. Okay, because welding of thermosetting is not possible, so we are talking about thermoplastic welding, welding of thermoplastics. Okay, so what is done? Simple, there is no complicated mechanism. Simply they are heated. Okay, and they get softened after heating, and after that we apply pressure. So the we get cross linking of polymer molecules. So this is what this is how the plastic thermoplastics are welded. We use filler material sometimes or not. So there are different types of plastic welding. These are, as I have talked, hot gas welding. These are mostly used: hot gas, hot plate welding, ultrasonic welding, spin welding, vibration welding, friction stir welding, and radio frequency welding. Now see hot gas welding. Hot gas welding, that means the on the joining area, hot gas is like it is applied. So that hot gas, they soften the two plastic sheets which is to be joined, and after that pressure is applied to join it. There is another one, that is hot plate welding, where two plates are used for welding purpose. So this heated plate, actually because the surface area of the plate is more, as much as we want we can increase the surface area of the plate, isn't it? We can take bigger plates also. So this is like this can give you more welding area in a very short time. Are you getting? So as much size of the plate is, that much we can do the welding. Ultrasonic welding, we have already experienced, or we have studied about ultrasonic welding, USW, in the last few classes. So there, ultrasonic frequency, with the frequency two surfaces which are to be welded, like vibration is applied on them. So that ultrasonic frequency, what is ultrasonic frequency? So above to 20,000 hertz. We know that our human capacity to hear is 20 hertz to 20,000 hertz, isn't it? So ultrasonic means beyond 20,000. That is known as ultrasonic welding, or ultrasonic frequency. So at that frequency, the like two spots, or we can say, they are oscillated and they are joined. A spin welding. So a spin welding is just like friction welding. Okay, we have also about friction welding. There are different types of friction welding, where spin welding is like we need to weld two shafts, let's suppose. So two shafts are like rotated in a, like if one shaft is rotated in clockwise, another will be a stationary. So because both are like there is a relative motion, so due to that there will be friction, and with that the heat will be generated, and that will after a certain time both will be pressed and there will be a joining. So actually we have already studied these methods of welding, so there is no there will not be any problem in understanding. Now we see vibration welding. This is similar to ultrasonic welding, but the problem is the vibration frequency is very less than ultrasonic. Here we are using more than 20,000 hertz. Here we are going for 500 to 600 hertz vibration, and the amplitude is high little bit. Here the amplitude is high, but here the amplitude is very less. So these are some of the differences. Friction stir welding. So already we have studied friction stir welding, okay, and we will talk about that also. Radio frequency, this is the new one, and after that there is another one which is known as laser welding. So we will talk laser welding in a great detail. So let us talk about hot gas welding. So hot gas welding utilizes hot gas, okay, and it is used for thermoplastics, and this is generally its applications are many, like containers, tanks, ventilation tubes, repair works. So these are some of the uses. Sometimes what happens is that polymers, this is very important, some polymers oxidize at increased temperature, therefore they are welded by hot nitrogen gas. Okay, so rather than applying any gas like hot air, we go for hot nitrogen gas, so that no oxidation will take place. So that is important in hot gas welding. So see, the question which has been asked in previous year is like write on the plastics or welding, plastic welding. So what you can write in a short note? So in a short note we can write about what is like what are the different types of plastics. Two are there, one is thermoplastic and thermosetting. And thermosetting is not welded obviously, and thermoplastics are welded. So there are different methods of thermoplastic welding. I have told three methods, that is one, mechanical joining, adhesive joining, welding, and the last one was the fourth one, that was cementing. So these are the four. Under welding, so mechanical joining we know by rivets, using rivets we do that. In case of adhesives, we use the adhesives. And welding, there are various methods. So as we have discussed already, that these are the different methods: hot gas welding, hot plate welding, ultrasonic welding, vibration welding, spin welding, friction stir welding. So these are the different welding methods. Okay, so and so this much is enough for 5 marks. Okay, little bit you can talk about hot gas welding. What is hot gas welding? So there what we are going to do, we are applying hot gas. In hot plate we are using heated plates. Ultrasonic welding, we are just like we have already talked, that ultrasonic frequency is used, and both the spots which are to be joined on the both the seats or both the parts which are to be joined, so they are oscillated at ultrasonic frequency. A spin welding, we have already talked that one is rotated against other, and due to that rotation there is some friction. Due to that friction heat will be generated, and there will be, after that, pressure be applied, and that's how the joining takes place. So in a spin welding, basically one of the parts must have circular cross section, otherwise it will not be possible, isn't it? Obviously, because for rotation purpose, for a spinning purpose, we require the cylindrical geometry, and also we require, it should, because see, if a spinning is required, so obviously we are going to hold that part into some machinery to rotate it at very high rotational speed. So obviously there should be some minimum strength which is required, or you can say minimum you can say hardness. Yeah, means it should not be bending, it should not be bending easily. So that is some limitation of a spin weld. So this little explanation is required, 1 or 2 lines from each welding methods we have to just write. So in that way it will be 5 marks question. Okay, so that's why I'm not going in great detail of applications and limitations. There are like, if we go on, then it will take a lot of time. Okay, and that much is not required, and that much you cannot remember even. So just that's why we are just going introductory about introductory explanation about welding processes. Now hot plate welding. So here we use the heat of hot plate placed between the surfaces to be joined. Okay, so here what is done, workpieces are pressed to the plate, heat up and soften. After a predetermined time, the plate is removed, the parts are brought to the contact, pressed and fused together. Okay, so what is happening, that there are 2 plates, and each plate is like each surface which is to be joined is like heated with the help of heated plate, hot plate. Okay, and after that the plate are removed, and then both the surfaces are brought together to join. Okay, so these hot plates are by aluminium. They are generally aluminium alloys, okay, more thermal conductive, and there will be electric heating elements, obviously, and thermocouple which will control the temperature. There are many applications like domestic electric devices like dishwasher, washing machines, vacuum cleaners. They are joined with the help of this. Okay, disadvantage is long welding cycle, up to 20 seconds for a small parts and up to 30 minutes for large parts. So here you see there is one advantage, that is large parts may be welded, which was not in the hot gas welding. Okay, so large part is possible, and high quality tight joints is possible in this plate welding, hot plate welding. But because time it requires a little bit higher. Ultrasonic welding, high frequency ultrasonic vibration is produced. Okay, ultrasonic 20 more than 20,000 hertz or 20 kilohertz. Okay, next, ultrasonic welding, the cycle is for 1 second. Yes, see how much fast it is, this welding. This is very fast welding process. Within 1 second the welding will take place. The vibration is in the range of 20 to 70 kilohertz. I told more than 20 kilohertz. Okay, and the amplitude is very very less, 0.05 mm, very less. But the problem is thickness of welded parts is limited. Okay, it's a limited, we cannot go for uh, larger thickness objects. So this is medical equipments, automotive components, there are which are costly materials, they are welded. Okay, only a small and thin parts may be welded, that is the disadvantage of it. Although short welding cycle is there, we can do automation, low energy consumption, this is also very important. I have already talked about ultrasonic, so these are the advantages of ultrasonic welding, but the problem is about the thin parts. A spin welding, I have already talked. Here is the spin welding, see here, these two components are there, and there one is rotated against other. Okay, and after once it acquires the sufficient temperature, after that they are pressed together. Okay, so this is how the welding takes place. Now here I have told that one of the component must be cylindric, having a cross-sectional area, circular cross-sectional area. Okay, and minimum rigidity which is required, because to hold this we require some rigidity. Vibration welding, I have told that certain frequency and amplitude, but not ultrasonic vibration, we don't need that. Okay, so here same thing is happening, is that rubbing action is happening, so due to the friction the heat is generated and then we apply pressure. So the welding cycle here is also very very less, that is milliseconds. The frequency is 100 to 500 only. In case of ultrasonic it was 20 kilohertz to 20 kilohertz. Here the amplitude is little bit more, that is 0.5 to 5 mm, and in that case, that is ultrasonic welding, it was 0.05. Vibration welding, so vibration welding is used in automotive and domestic appliance industries. Okay, oxidizing polymers may be welded, easily automated, highly productive, large and complex parts may be welded. But disadvantage is expensive and minimum rigidity is required. Means to hold these parts, we requires a little bit rigidity in the plastics. If there is no rigidity, we cannot go for vibration, because see where the vibration will happen. If these surfaces they will apply a little bit of pressure, then they will bend, so there is no chance of vibration and friction and all, so there is no chance of heating and there is no chance of welding. Okay, so rigidity is required. Friction stir welding, we have already seen that we use a tool, okay, this kind of shaped tool, and these two surfaces are brought together, and in between at the junction of these two surfaces, this is butt joining, isn't it? So at the junction of two surfaces, this tool is rotated and they create, due to the friction, these two surfaces are melted, heated, and due to the pressure, see the pressure is applied, due to that pressure the joining takes place. But there is some problem, that is the strength reduces at the joint place, the strength reduces to 50%. Yeah, so why it happens? Because of the, you know, the crystalline material here has reduced to has become amorphous, that happens. Okay, so that is the problem. Radio frequency, so internal heat generation, here see we are in like generating the heat internally, as we have done in ultrasonic welding. Okay, so same thing here also, internal heat generation by dielectric hysteresis losses in thermoplastics. Okay, so on the surface you will not see anything. When the two surfaces are joined together, you will not see anything, any effect on the surfaces, but you will see that in place the both the because of the localized heat generation at the joining places, they will be joined together. Okay, so here what we are using, rapidly changing electrical field. Okay, and this results in intermolecular friction and heat generation. The time cycle time is 1 to 5 seconds, very fast. Okay. And but it is used only for thin sheets mainly, that is 1.27 maximum. And the point is that very important, that is it should have high dielectric loss. The material should have high dielectric, that means like the heat generation should happen, the resistance due to the dielectric, uh, you can say hysteresis losses. We have studied in electricals in first year hysteresis loss what it is, so I'll not go in the detail. So generally this is the common material, which is PVC, which is used for uh, welding using this method. Okay, so we will stop here only, and in next class we will talk about the laser welding which is used in welding of either glasses or plastics or ceramics, so other methods. So we will talk in the next class. Thank you very much.